Today we are going to discuss about functions. So, what do we mean by a function? So, this is it is a rule which assigns to each element x in some subset D of R exactly one element, and we call this function f, and that means f will take, according to certain rule, will take each element of D. Suppose x belongs to D, then it will assign one value real number for each x, that is f x. So, it cannot assign two values for one element. However, it can assign one value for two different elements, but it cannot assign two values for one element of D. We call that as a function, and symbolically we write this as f is from D to R, or we may say f is a map from D to R, where D is a subset of the real number. So, now the set D, where each element of D has been assigned one number, is called the domain of the function f. And if I collect all those f x for x in D, this is going to be a subset of R. This we are going to call as a range of the function f. And in this case, the element of D, which are we are denoting it by x, they are called independent variable. And if I write y is equal to f x, so this is a dependent variable, that means y, this is dependent on x. If I change the x, then our y is also going to be changed. So, it is dependent on x. So, this is what it is called the dependent variable. Now, simply for example, if we consider the area of a circle, then this is going to be a function of R. Different size of circle will have different areas, and this area is going to be dependent on the radius. The larger the radius, we will get the area of the circle to be larger. So, that means the area we can write it as a function of R, and which we denote it by the formula pi r square. So, depending, once we vary R, then the area will vary accordingly. Here in this case, R is the independent variable and A is the dependent variable. So, now we have a function which domain, the range of a function, independent variable and dependent variable. So, let us see some concrete example. So, we will write the function, their domain and their range. Now, let us consider f of x equal to x. Now, this function is defined for every real number, we can define it for every real number f of x equal to x. So, trivially the domain is R and the range is also R, because it is going to take each and every real number, there will be a corresponding x which is f of x equal to x. Now, if we take f of x is equal to x square, then the domain of this function is entire R. However, the range is the interval 0 closed, infinity open. For every real number, the square of the real number exists, that what we had seen previously, x into x, because we have a prescription for multiplication. And now, The range is 0 infinity, that means once we take any real number, non-negative real number, we have also seen that there exists a number y such that y square equal to x, that is what this. So, now the range is closed 0, infinity open. Now, if I take f of x is equal to square root of 1 minus x square, here the square root can be defined for non-negative real numbers, and here we are considering the positive square root. Now, in the non-negative real numbers, that means our 1 minus x square has to be greater or equal to 0. That means x square has to be lesser equal to 1, that means x has to be between minus 1 and 1. So, the domain is going, in this case, is going to be minus 1 1 closed interval minus 1 1. What will be the range? We are taking the positive square root as the function, therefore, the range is going to be closed 0 closed 1. Now, if you consider the function f of x is equal to 1 upon x, then at x equal to 0 this function is not defined. So, the domain is going to be R minus singleton set 0, and the range is also going to take every value of R except 0. Range is not, there is no real number x such that 1 by x is equal to 0. So, this is what is the range. Now, if we look at the function f of x equal to 2 plus x by 1 plus x whole square, then as you can see that this f cannot be defined for is going to be 0 if x is negative 1. Therefore, so the domain of this is going to be entire real line minus the singleton negative 1. And what will be the range? Of course, there is a square here, therefore, the range has to be, will be a subset of non-negative reals, and for which can there be some real number which cannot be attained by this function? Of course, 1 cannot be attained. So, in that case what it is going to get is that 2 plus x by 1 plus x is going to be either plus or minus 1, which is not possible. So, then we have trigonometric function f of x sin x. In this case, the domain is going to be the entire real line, and the range sin x can take the value between negative 1 to positive 1. So, these are all some of the examples of the functions what we have seen. So, let us look at some practical example. Now, it is given a rectangular storage container with an open top, which is a box, has a volume of 10 meters cube. The length of its base, this is twice the width of its base, it is given. Material for base costs 1000 per square meter, means to construct this portion what it is needed, that it will be 1000 per square meter. And for the sides, this means this side and this side, there will be 4 sides. The material cost is going to be 600 per square meter. Now, express the cost of the material as a function of the width of the base. Okay, so, now it is simple. So, what is the area of the base? Area of the base is, one side is 2 w and another is w. So, 2 w square. Let me take w to be the width of the box, then this is 2 w. So, area of the base is 2 w square. Now, the area of the sides, these two sides are going to be 2 WH plus 2 WH 4 WH, and then these sides are WH plus WH 2 WH. So, this is going to be 6 WH if we are considering H to be the height, this is H. So, the total cost C, who is going to be in terms of the rupees, 1000 into 2 W square, that is the base, and then sides are per square meter is 600 rupees. So, therefore, this is 600 into 6 WH. So, this is the total cost. What is our purpose? Now, we want to express the cost of the material as a function of width of the base, which means we need to write this C in terms of W, which means C is a function of W, that is what we want to do. In order to do that, we need to eliminate H. Now, what is the condition what we had been given with? Now, the condition is given that the volume of this is going to be 10 meter cube. Now, what is the volume? So, the volume is this area 2 W square into H. Now, 2 W square into H is 10, therefore, H is 10 by 2 W square. Therefore, simply in this formula we can put the value of H. So, what we are going to get that this is a function of W only. Okay. So, now the very useful way of kind of studying the function is to visualize the function. That means, what we need to, we can, if we can sketch the function, then that is going to be then we can understand the function better. So, this is called the graph of the function. So, let our function f is from D to R. D is the domain and R here, that means D to R is that there will be some subset E such that f is a map from D to E. Here we are not saying that the range of f is R, range of f is a subset of R. So, this is what is the meaning of this symbol. Then the graph of this function f, this is defined by x f x. Given one x in D, there is an f x. So, this ordered pair f x f x is called the graph of the function, and this set, now this set is in the plane, x comma f x is element in the plane, and so when x varies over D, the domain, then this is going to be a set subset of the plane. Now, we need, if we want to, let us see how to draw this. Suppose I have f of x equal to x square, that means the graph what we want to do is that x square such that x, this function is from, the domain is from R to R and x belongs to R. So, now this is what it is going to be at 0, this is going, this is a parabola, all of us we know, and this is 2 4, on the positive side this is going to be large, and on the negative x this is also going to take the non-negative value, positive values. Similarly, let us try to see the graph of another function, which is x is the y is equal to x to the power 1 upon 3. What we know earlier is that in order to define the rational power of this, sometimes we need to be careful about choosing our domain. Suppose if it is x to the power 1 by 2, then we have to be careful about that we cannot define this function for negative x, but in this case x to the power 1 by 3. Now, what is going to be the domain of this function f? This is going to be the entire R real line, and this function is going to look like this. This is if you compare this. So, this is around 0, this is 0, at 0 and then this is 1, it is 1, 2 is 2 to the power 1 by 3. So, it is going like this. Okay, so, there are some functions we can sketch, the graph of the function can be easily seen. Now, what we have seen is that the graph of the function, it is going to be a curve in the plane, it is some curve in the plane. Now, the question one can ask that natural to ask that if I give you a curve, is it necessarily true that there is a function f such that this curve what I had given you is going to be the graph of that function? Here actually I am little sloppy in not defining what I mean by a curve, but intuitively you know what a curve is. So, by the following test we can answer this question. So, now this is the test simply says that okay, look at the function, what is the function what we have defined. For every x in the domain there is one element corresponding to that, but for there cannot be one element cannot corresponding to two values, means f of x cannot be y 1 as simultaneously y 2, that is the rule of the function, that is what we call it as a function. In other words, it cannot be one many. So, now this test says that a curve in xy plane is the graph of a function f. Any curve is a graph, there is a function f for which the graph is the curve if and only if no vertical line intersect the curve more than once. So, you take the various vertical line. So, it should intersect the curve only at one point, it cannot intersect more than one point. For example, in on the left hand side of this, you take any vertical line. So, this is going to cut this curve only at one point. However, in contrast to this, if I have a curve like this, then this is the vertical line, this is going to cut this. So, this is cannot be a graph of a function f, whereas this is. Okay, so, now we can if we had been given, so you know given two real number we can add. So, we can give a prescription given two function whether we can add these two functions or not. That will be interesting. Given f is a function, g is a function, then we have a prescription, we can define the addition of two function f plus g, we will denote this as the addition of the function by this f of this is equal to f of x plus g of x, because now f of x is a real number, g of x is a real number. So, the right hand side addition is pretty much well defined, and this is what is in the left hand side, the addition of two function is being defined like this. So, which means in the set of functions, now we are introducing, we are giving a prescription in which we can add two function. Similarly, we can multiply by a scalar. Now, if alpha is any real number, then we can define alpha times f. This is going to be a function, and what is that function? The function would be, we will define it to be alpha into f of x. Now, again now f of x is a real number, alpha is a real number, and we can multiply two real numbers. So, this is on the right hand side, it is alpha times f of x is a very well defined number, and on the left side we are defining now the scalar multiplication on the set of all functions. Similarly, we can define the multiplication of two functions. If we have a function f and we have a function g, then we can define the f times g, f multiplied by g. This itself is a function, we call that as f g. Now, how it is defined? This f g is f of x into g of x. Now, if I have a function like in the real number, if I have a number not equal to 0, then I can define 1 over that. number. So, exactly in the same case, if g of x is not equal to 0 for any x in the domain D, and where f is also, then I can define this concept of f by g. F by g as a symbol, which is kind of a division, is equal to x equal to f of x by g of x. Now, for each x in D, g of x is not equal to 0. So, I can talk of f of x by g of x, because both are now real number and g x denominator is a non-zero real number. So, this is what we can have a prescription of division. So, in the set of functions we have the prescription to add, we have the prescription to scalar multiply, we can multiply two functions, and we can divide a function by a non-zero function. And there is another very interesting operation is there on the set of functions. There we have to be really careful about it. Now, if f is from D to R and g of x belongs to D, then we can define the composite of the function f composed with g at x, which is equal to f of g x. You see, now this g x now is in D. Now, f can act on this g x. So, now if this g x goes outside D, then the right hand side has no meaning. Therefore, here we have to be careful that essentially the range of g should be inside the domain of f. Then we can define. So, here what we are saying, the range of g is contained in domain of f. So, let us see one concrete example of this. Now, you define f of x equal to square root of x. Now, what is the range of f here? Now, the range of f is nothing but, now here in this case the domain of f is 0 infinity, because for the negative one. Now, g of x equal to x plus 1. Now, in order to define f composed with g, we can only define it if this x plus 1 is greater or equal to 0. That means, x has to be greater or equal to minus of 1. Therefore, f composed of g is can only be defined on negative 1 to infinity. Then g is going to take me the value to 0, g of x is going to be inside 0 infinity. Therefore, f can act on g. So, if we write down f composed with g of x is equal to square root of x plus 1, because now this is f of g of x is equal to f of x plus 1, then this is going to be f composed with g at x, which is equal to f composed with f acting at g of x, which is equal to f of x plus 1, which is nothing but square root of x. So, in order to do this, we need to ensure that x plus 1 has to be greater or equal to 0. Now, function can sometimes be defined not necessarily on one domain, there will be one formula in which you can define the function. For certain portion of the domain, the function is defined in some way, and for other portion it can be defined in a different way. That is what we call it is the piecewise functions. So, now the function which is defined by different formulas in different parts of its domain is called piecewise function. For example, you look at this, f of x equal to x if x is lesser equal to 1. and f of x equal to x square, it changes its course when x is greater than 1. So, this is now if I want to see the graph of this function, then up to 1 this is x, which will be a straight line passes through the origin. So, this is going to be f of x equal to x up to this 1. Now, after 1 it is going to take the value of x square. So, now this is what the function is going to look like. Okay. Now, a very important concept is the absolute value of a real number. It essentially says that this is the real line if we want to take now suppose my x is here, then this is 0, then the absolute value of x is essentially this is the distance from 0 to x. Now, if my x is here, then this is also the kind of the distance what I am going to take on the negative side, and that distance is always a positive, that what we can. So, this is f of x mod x equal to x if x is greater or equal to 0. Now, minus of x if x is if x is less than 0. Now, let us try to sketch this. So, mod x f which is equal to greater x, and then on the negative side it is minus of x. If it is x, then it will go like this, but minus of x is the negative of x. So, this is going to be like this. So, this is what is the. Now, similarly f of x, this is a kind of the composition function with f with the g is f is mod x and g is x minus of 1. Now, if I want to write down this value, this is going to be x minus of 1 if x minus of 1 is greater or equal to 0, that means x is greater or equal to 1. Now, this is going to be minus of x minus of 1 if x minus of 1 is less than 0, that means if x is less than 1, this is going to be 1 minus of x. Now, if we try to sketch this, as you can see, when x is equal to 1, this is going to take the value 0, and then on the greater than 1, this is going to be x minus of 1, and when x is less than 1, this is also going to be a positive number, but this is going to this. So, this is what is the graph of the function f of x. Okay, so, now we are going to discuss another function which is very useful and you are familiar with, that is greatest integer function. How it is defined? Now, greatest integer function is the greatest integer less than or equal to x. Let us draw its graph. Now, I have 1, 2, 3 and on this side negative 1, negative 2, negative 3. Now, if you look at your x between 0 and 1, then what is the value it is going to take? It is going to take the value of 0. Now, anything if x is greater than 1 and less than 2, then the bracket x, this is going to be equal to 1. So, that is what we will get. Now, between 1 and 2, 2 is not included. So, this is basically the interval 1 and 2 open. This is going to be 1. Now, if you go from 2 closed, this is 2 close to 3 open, then this is going to take the value of 2. Similarly, now on the negative side, if I want to, if your function is minus of 1 0 open, minus of 1 closed, then what you are going to get, that this is going to be negative of 1. So, this is the greatest integer, because your x is where this. Now, the greatest integer less or equal to x is nothing but negative 1. Similarly, if your x is here, then this is what you are going to get the value of negative 2. So, this is what is your function will look like in this interval. So, this is -2 to -1 open, this is going to take the value negative of 2. Now, in similarly on this interval, this is going to take the value -3. So, that is what is the greatest integer function. It is something like a staircase, you know, this is the stair, then 0, then this, then. So, this is the staircase function, it is also known as. Thank you for your attention.